So here we have question 2 from paper 2 of the SQA Higher Maths paper 2012. A circle and a straight line which intersects it at points B and Q. And information we're given is that the equation of the straight line is 2x minus y plus 5 equals 0. Something that's true for the values of the x and y coordinate of every single point in that line. Also similar sort of information given for every point that lies on that circle. We're told that if we know the values of the x and y coordinate of a point in that circle, then x squared plus y squared minus 6x minus 2y minus 30 is equal to 0. So these two relationships hold for all points on the line, this one, and for all points on the circle, this one. Now what's special about the points of intersection is that both of these relationships hold for the x and y values of these 2 points. So not only does 2x minus y plus 5 equal 0 for the x and y coordinates of these 2 points, but also we know that x squared plus y squared minus 6x minus 2y minus 30 is equal to 0. So they hold together simultaneously, and we have to solve these 2 equations simultaneously. Now, the first one, if we add y to both sides of this first one, on the left-hand side we'll get 2x plus 5, the negative y will disappear, and if we add y to the right-hand side, we'll get y. In other words, the y coordinate is twice the x coordinate plus 5. That's true for these 2 points. And what also is true for these 2 points with values of x and y is that this relationship holds. So since y is twice x plus 5, we could replace y in this second relationship with 2x plus 5. So instead of x squared plus y squared, we can write x squared plus 2x plus 5 squared. And instead of minus 2y, we can write minus 2 lots of 2x plus 5. Now we can only do this substitution, as it's called, substituting 2x plus 5 instead of y, because both these relationships are true for the values of x and y on the 2 points P and Q. They lie on the line and also the circle. So this last equation has only x as a variable. One equation, one unknown, we should be able to find the value of x. So let's try and multiply out 2x plus 5 all squared. Let's have a look at that one. 2x plus 5 times itself. To do a firsts, outsides, insides last on this one. The first 2 terms multiplied give us 4x squared. The outside 2 terms, 2x times 5 is 10x. And the inside 2 terms, 5 times 2x is 10x. And multiplying the last 2 terms together gives us 25. So we'll get a 4x squared, a couple of 10x's, that's 20x, and a 25 for the constant term. So let's write that down. That takes care of the squared bracket. Still to subtract 6 lots of x, and minus 2 lots of 2x plus 5. Well, careful with the signs here. Outside the bracket there's a negative 2 times this 2x, and then a negative 2 times this 5. So we'll have a minus 4x, it's negative 2 times 2x, and negative 2 times positive 5 is negative 10. So that gets rid of that bracket, and we've got a constant minus 30 at the end. The whole thing comes to 0. So a little bit of tidying up. Let's count the number of x squared terms. There's 1 of them here, 4 of them there. That's 5 of them. The x terms, 20 of them there, minus 6, minus another 4. Well, we're taking 10 altogether away from the 20. That'll leave us 10 lots of x. And in the constant terms, there's 25 minus 10 and minus another 30. We're taking 40 away from 25, giving us minus 15. Now you'll notice there's a factor of 5 in each of these terms, which we could take out as a common factor. Now because we're in an equation, we can divide both sides of that equation by 5. A fifth of 5 lots of this would just be 1 lot of it. So the 5 goes, and we're left with 1 lot of x squared plus 2x minus 3. And in a fifth, or 5 into 0, just gives me 0. Typical quadratic equation, can try and factorize this and hope it works. For the first two terms, only one choice is x times x. Only one choice for a 3 would be a 3 times a 1. And the outside terms give me a 1x, and the inside term give me a 3x. So the only problem now is how do we get this 2x from the 3x and 1x? Well, it'll be plus 3x minus the 1x. So I have a plus 3x minus 1x. Remember always to double check these things, doing your first, outsides, insides, last. So x times x is x squared, outsides minus 1x, insides plus 3x, that does give us 2x, and positive 3 times negative 1 does give us negative 3 for the last term. So x plus 3 times x minus 1 is 0. Something times something 0. One of these two factors must be 0. So either x plus 3 is 0 or x minus 1 is equal to 0. And we know that x plus 3 equals 0 would mean x is negative 3. And if x minus 1 is 0, x would be 1. So looking at diagram, x coordinate of p would be the negative 3, and then to the right of that, x coordinate of q would be 1. We still have to find their y values, so let's calculate them. When x equals negative 3, now for the point P, we either use the line equation or the circle equation. Much prefer using the line equation. It's much simpler, and we can get our y value very much easier from that one. So when x equals negative 3, 2x minus y plus 5 equals 0 gives, well, we should have used the y equals 2x plus 5, which would already worked out. That's a lot easier. So it's twice the x coordinate, twice negative 3 plus 5. 2 lots of negative 3 is negative 6. Negative 6 plus 5 is negative 1. And let's, while we're at it, work out the y value when x is 1. When x equals 1, y equals 2x plus 5 gives y equals 2 times 1 plus 5. So that's 2 plus 5, which is 7. So P is the point negative 3, negative 1, and Q is the point 1, 7. Check on your diagram that that makes sense. We've already decided that negative 3 is to the left of 1 for x. We've now got a negative 1 and a 7 for the heights, negative 1 for the height of P, 7 for the height of Q. That looks reasonable. So let's just record that information for the second part of the question. We'll need to refer to that. So P is the point negative 3, negative 1. Q is the point 1, 7. And let's get rid of all that working. And let's look at the second part of the question. So we're given the information that another circle, exactly the same size as the first circle, also passes through the point P and Q. Congruent means identical. Radii will be the same of these two circles. So to get a feeling for this, let's have a wee look at a larger diagram. So here's a larger diagram, and it's to give you a feel for the symmetry of the situation. Let me move this around. Always two congruent circles, and the chord joining their 2 points of intersection, that line is always shown. Now think of the symmetry of this situation, where the centres lying on either side of this line of symmetry, this line, the red line there, is always a line of symmetry. Let me put in the two centre points. There's one and there's the other, A and B. And let's move that around. You keep your eye on the position of these two centres with relationship to the red line. We can see it even better if we draw in the perpendicular bisector of the line joining Q and P. There it is. And you'll notice it's at right angles to the chord PQ, and that the two centres lie equal distances from that line. So we've got this perpendicular bisector. This point here is the midpoint of chord PQ, and the line joining these two centres is at right angles to that. So symmetry property becomes very apparent when you move this diagram around. So bearing that in mind, let's go back to the original diagram. So knowing that the symmetry is vital and finding centre and radius is crucial for finding the equation of a circle, let's take the first circle that we had and determine where its centre is and what its radius is. The equation is x squared plus y squared minus 6x minus 2y minus 30 equals 0. To get the centre, which we can call A, here's the procedure. Check first that there's one x squared and one y squared, otherwise this procedure does not work. Look at your x coordinate and your your x coefficient and y coefficient. Half it and change the sign. Half it and change the sign. That gives you the coordinates of the centre. The radius can now be obtained by taking the square root of this x coordinate squared plus this y coordinate squared minus whatever the constant term is up here. And in this case, it's minus 30. So that gives us the square root of 9 plus 1 plus 30. That's the square root of 40. So that will be the radius not only of this first circle, but also the second circle. Now, to find the centre of the second circle, remember from the diagram I showed you, the moving diagram I showed you, the midpoint of the chord PQ, where that's the point -3, -1, and this is the point 1, 7, the midpoint will lie on the line joining these two centres, and again, by symmetry, that'll be also the midpoint of the line joining these two centres AB. So basically the journey from A, the centre, which is 3, 1, to M, that midpoint, AM, will be the same as the journey from M to B. And we'll be able, therefore, to find that centre using vectors, or the vector journey that we've taken going from A to M. So let's first of all find the midpoint. The midpoint M of PQ is, now it'll be the average, the mean of the two x coordinates, which were -3 and 1. So it's -3 plus 1 halved, and -1 and 7, the mean of these two values. Remember, it's the midpoint. -1 plus 7 over 2. Maybe never needed these extra brackets. So -3 plus 1 is -2, divided by 2 is -1. -1 plus 7 is 6. 6 over 2 is 3. So that centre point is -1, 3. So let's now look at the journey from A to M. Which would just be the position vector of M minus the position vector of A, which is -1, 3 minus 3, 1. -1 minus 3 is -4. 3 minus 1 is 2. You can check that if we travel from an x-coordinate of 3 along to an x-coordinate of -1, we'll have gone 4 to the left. That's the -4. And if we travel from a height, a y-coordinate of 1, up to a y-coordinate of 3, we've gone up 2. That gives us that. Similarly, the journey from M to B will also be -4, 2. Now, if we're starting out with an x-coordinate of -1, travelling 4 to the left, that implies B has a x-coordinate of -5. Let's repeat that. We're travelling -4 to the left along parallel to the x-axis, and we are at -1, and -4 to the left will take us to -5. Also, at M, y-coordinate is 3, we're at a height of 3, we have to go up a further 2 steps, so that'll take us up to a height of 5. So, the centre of second circle is -5, 5, and its radius is square root of 40. So its equation is, now you may recall the information that if you have a centre AB and a radius R, then the equation of the circle with that centre and that radius is x minus a squared plus y minus b squared equals r squared. So in this case, the equation will be x minus the -5, square that term, plus y minus the 5, square that term, and that'll give you the radius squared. So tidying that up, we don't need to multiply out all these squared brackets for the marks for this question. So x plus 5 all squared plus y minus 5 all squared is equal to, now square root of 40 times square root of 40 is just 40. So there is the equation of that second circle.